introduction to differentiation, where we use the first principle of differentiation and also the technique to differentiate the function. Now we want to move on how to differentiate the composite function, how to use the product rule and quotient rule to do a process of differentiation. Let's start. Okay, before we go to the rules of differentiation to differentiate the composite function, let's see what is actually the composite function. So the composite function is actually the function that is inside another function. Means that you have two different functions. Okay, one function is inside another function. For example, if I have one function, let's say y equal to 7x to the power of 2 plus 3 to the power of 5. Okay, so you can see here as one function, but it's actually two different functions. What is the first function? The first function is the one inside the bracket here. This one is the first function. Okay, and the second function is the whole things here. So if I substitute the one inside the bracket here with the simple constant, let's say a, I can write this equation y equal to a to the power of 5. Okay, so a here, 7x to the power of 2 plus 3, is a function that sits inside the function of a to the power of 5. Okay, so this one is a composite function. So when we have a composite function, for us to differentiate the composite function, we cannot use the basic differentiation technique. For example, if you have y equal to 7x to the power of 2 plus 5x power of 2, then this one may be easier because you can expand your equation. It can be y equal to 7x to the power of 2 plus 5x multiplied by 7x to the power of 2 plus 5x. Then you just need to expand all the term here and differentiate your equation by using the basic technique of differentiation that we learned before. But if we have one composite function with the power more than 2, let's say we have 7x squared plus 5x to the power of 4, so it will be complicated for us to differentiate by using the basic technique of differentiation. So this is called as a composite function, and for us to differentiate the composite function, we need to use some techniques. We have two methods to differentiate the composite function. The first one we call as a chain rule, and the second one we call as a formula. Okay, we use a formula to differentiate our composite function. So when we want to use the chain rule, first of all, we will let our function y equal to fu, the function of u. And the one inside the bracket here is our u. Okay, so for example, if you have y equal to 7x squared plus 5x, you will let your y equal to u to the power of 4. And what is your u? Your u is the one inside the bracket, another function, which is 7x squared plus 5x. Okay, so you can see here, now you have two different equations. The first equation is y in terms of u, and the second equation is u in terms of x. So when we want to do a process of differentiation, we will differentiate these two equations separately. The first one, we will differentiate the equation y in terms of u. So what you will get here is not dy dx, but you will get dy du, since you are differentiating this equation with respect to u. So what will happen? We will use the basic technique with two steps. Step number one, the power here you bring in front and you multiply with whatever coefficient you have in front. So now the coefficient you cannot see means that you have 1 in front. So 4 multiplied by 1, you will get 4u, and the power here is minus 1. So you have 4u to the power of 3. Okay, and then we differentiate u, and we need to differentiate u in term of x because we have the equation in term of x. So what you will get is du dx, the differentiation of u with respect to x. So we do the process of differentiation as usual. Okay, bring the power here in front and multiply with the coefficient. 2 multiplied by 7 is 14x. And the power here you minus with 1, you have x to the power of 1. No need to put 1 there. And this one, you have x to the power of 1. You cannot see the power because the power is 1. So do a process of differentiation. 1 multiplied by 5, you will have 5x to the power of 0. So again, x to the power of 0 is equal to 1. Therefore, no need to put x to the power of 0 behind 5. Okay, so now you have dy du and du dx. But what you want here is the differentiation of this function y in terms of x, which is you want to find dy dx. Okay, what you have here is dy du and du dx. But what you want is dy dx. So by using chain rule, you can find dy dx by multiplying your dy du with du dx. How? Because when you multiply dy du and du dx, you can see the denominator here is equal to the numerator. Therefore, you can cancel out. So what you will get is dy dx, the one that you want to find. Okay, so by using chain rule, you can find dy dx by multiplying your dy du for u to the power of 3 with 14x plus 5. Multiply with 14x plus 5. And don't forget to substitute back what is your u. Your u just now is 7x squared plus 5x. So what you have here is 7x squared plus 5x to the power of 3 multiplied by 14x plus 5. So this one can be accepted as the final answer. Okay, that one is how we finding the differentiation of the composite function by using chain rule. How if we want to find the composite function, the differentiation of the composite function by using formula? Okay, let's say we have the same question here. Okay, we have y equal to 7x squared plus 5x to the power of 4. Now, I want to use the formula. Okay, so we will check either we will get the same answer or not, like we used the chain rule before. So now class, how to use the formula? If you can remember our two-step technique, which is the first step is you need to bring the power in front and multiply with whatever coefficient that you have outside the bracket. If you cannot see any number here, means that in front here you have 1. So 4 multiplied by 1 is equal to 4. Now you are finding dy dx. And then step number 2, you need to minus the equation, the power here with 1. So you need to copy everything inside the bracket. Okay, and the power now left only 3. That one is step number 2 for differentiation. For composite function, we have step number 3 where we need to multiply all the equation that we have here with the differentiation of whatever equation that you have inside. Okay, so you need to multiply by differentiation of whatever equation you have inside the bracket. So you differentiate 7x squared, you will get 14x, plus you differentiate 5x, you will get 5. So this one is the answer. You can see the answer is equal. Either you use the formula or you use the chain rule to differentiate the composite function. Okay, let's see example to differentiate the composite function. Let's say we have to differentiate y equal to x squared plus 1 equal to 5. So again, the composite function is actually the function inside another function. So if you see here, you have one function. If you change this y in terms of u, you will get the first function as y equal to u to the power of 5. Where you substitute everything inside the bracket with u. So your u actually everything inside the bracket x squared plus 1. Okay, so now next is you need to differentiate both term y and u. Okay, so differentiate y in term of u. What you will get here is dy du. Okay, differentiate 5, you bring in front, multiply by 1, so you have 5 u, and the power u minus 1, so you have 5 u to the power of 4. And then you need to differentiate u with respect to x, because you have equation u in terms of x here. So du dx, you will get, okay, 2, bring in front, multiply by 1, you will have 2x. Okay, differentiate constant. Remember, differentiate constant is equal to 0. So you have your du dx equal to 2x. Now, what you have is not dy dx. You have dy du, you have du dx. But what you want is dy dx. Okay, so by chain rule, how to find dy dx? You need to multiply dy du multiply with du dx, because it can be eliminated and you will get in return dy dx. So what is your dy du? Your dy du is 5u to the power of 4. Okay, and you need to substitute back what is your u. So your u is this one, x squared plus 1 to the power of 4. Okay, multiply by your du dx, which is 2x. Okay, so this one can be considered as a final answer, or you can multiply 2x, you can multiply with 5 in front here. So you will get dy dx equal to 10x, and in the bracket you have x squared plus 1 to the power of 4. Okay, the final answer by using chain rule. How if the same question we want to solve by using the formula? For example, you have y equal to x squared plus 1 to the power of 5. So we want to use the formula. So remember, what we want to find now is the differentiation of y in terms of x. So you will get in return dy dx. Okay, and use the two-step technique of differentiation. Power, bring in front, multiply by any coefficient that you have. You cannot see means that in front here you have 1. So 5 multiplied by 1, you will get 5. And the power back here, you need to minus with 1. So you need to copy whatever you have in the bracket, x squared plus 1 to the power of 4. And remember, whenever you are differentiating the composite function, you need step number 3, which is you need to differentiate whatever you have in the bracket. You need to multiply with the differentiation of x squared, which is you will get 2x, and the differentiation of 1, which is you get 0, so you have 2x here. So finally, your final answer will be dy dx is equal to, I multiply 5 with 2x, you will get 10x x squared plus 1 to the power of 4. So you will get the same answer either using the chain rule or using the formula of differentiation. Okay, let's see another example on differentiation of composite function. Okay, let's say we want to differentiate 1 over 6 to the power of 3x plus 2, 1 over 6 multiplied by 3x plus 4 to the power of 2. Okay, so how to differentiate? Remember, I told you before, when you want to do a process of differentiation, the variable that you want to differentiate cannot be in the denominator, cannot be in the bottom. You need to bring to the top of the fraction. Okay, so whenever you bring the variable to the top of the equation or to the numerator, the power will change. The sign of the power will change. If the original power is positive, then it will become negative. If the original power is negative, when you change the position, it will become positive. So now you have 1 over 6 3x plus 4 to the power of 2. So which one you want to bring on top is this one, the one that have power. 6 just remain in the denominator. So now if you can see before, the power is positive 2. So when you bring it on top, it will become y equal to 1 over 6 3x plus 4 to the power of negative 2. Okay, to the power of negative 2. So now, if you want to use the chain rule, you need to break your equation into two different equations. And remember, the one that is inside the bracket will always be u. So write your u, you have your u equal to 3x plus 4. So you substitute everything here with u, you will have your y equal to 1 over 6 u to the power of negative 3. To the power of negative 2. Okay, so now you can differentiate both equation. Differentiate the first equation, you have u in term of x. So when you differentiate u in term of x, you will get du dx. Okay, so differentiate 3x. Differentiate 3x, the power here is 1. Bring 1 to the front, multiply. 3 multiplied by 1 is 3. X, 1 minus 1 is 0. Differentiate positive 4, which is constant. Differentiate constant is always equal to 0. So, because we know that x to the power of 0 is equal to 1, no need to put. So, your du dx is equal to 3. Okay, and then now you want to differentiate your y, but your y now is in term of u. So, you not get dy dx, but you will get dy du. We are differentiating y with respect to u. So use two-step technique. Negative 2 you bring in front and multiply by the coefficient, which is 1 over 6. So negative 2 multiplied by 1 over 6, you will get negative 1 over 3 u. The power here u minus with 1, so you will get the power negative 3. Okay, class. So now you already have du dx and dy du. By using chain rule, to find dy dx, you need to multiply dy du with du dx that you have. You have here du dx and you have dy du. You need to multiply both of these to get dy dx. Why? Because we can eliminate du here and you will get dy dx. So, your dy du that you have here is negative 1 over 3. Okay, negative 1 over 3 u to the power of negative 3. You need to multiply with your du dx. Du dx is equal to 3. Okay, and then you can multiply. 3 multiplied by negative 1 over 3, you will get negative 1 u to the power of negative 3. And remember, you need to substitute back what is your u. Your u just now is 3x plus 4. So substitute back, you will get negative 1, 3x plus 4 to the power of negative 3. This one is your dy dx. Okay, so if you want to leave your answer here is or k, but you can rearrange, put back the negative here to the denominator. Okay, so what you will have is dy over dx equal to -1 on top, and at the denominator you have 3x plus 4, and the power negative become positive because you change the position. So this one is the differentiation of your function. Okay, this one is by using the chain rule. How if we want to use the formula? Okay, so to use the formula, let's say I rewrite the same equation. Okay, here you already have the step. Okay, we just need to, I just want to show you the real step. So let's say you have this equation. So you have y equal to 1 over 6, 3x plus 4 to the power of 2. Remember, whatever you want to differentiate cannot be in the denominator. Therefore, you need to bring this one on top, and the sign of the power will change. So what you have actually is the function or the equation y equal to 3x plus 4 to the power of -2 divided by 6. Okay, so now we can find dy dx by using the formula. The first step is to bring the power in front and multiply with whatever constant that you have in front here. You cannot see anything, right? Means in front here you have 1. So -2 multiplied by 1, you will have -2. You need to copy back 3x plus 4. The power here -1, you will get -3. And don't forget that you have 6 in the denominator. Okay, but when you are dealing with the composite function, you have step number 3. Where the step number 3 is to differentiate whatever you have in the bracket here. You need to differentiate. You need to multiply by the differentiation of 3x, which is 3. Differentiation of 4 is 0. Okay, and then you can simplify. -2 multiplied by 3 is -6. -6 divided by 6. So you have your dy dx equal to -1, 3x plus 4 to the power of -3. And again, you can bring it down in the denominator. You will get the same answer as one that we use the chain rule. Okay, so that one is how we can differentiate the composite function.